Good day, everyone, and welcome to this Gradle webinar. I'm your host, Oliver White, and joining us today for Developer Productivity with Apache Maven, 18 Hacks to Accelerate Your Builds and Tests, is my friend and colleague, Brian Demers. Brian is a Java champion, long-term committer to Maven and various other Apache projects, a developer advocate at Gradle, and an expert beekeeper. You may have seen Brian talking at various Java conferences around the world. Today, he will review 18 tips and hacks, all free or OSS, to make your Maven experience more productive and less miserable. Some of these tips are low-hanging fruit for even Maven beginners and are likely familiar to some of you. Other tips will probably need more thought and planning, even for Maven experts. Either way, following this advice will make a meaningful difference to your developer productivity. That's our hope. Plus, being able to observe and report productivity boosts to your managers and executives is also always a good thing. While we wait for others to join and get settled with their coffee, tea, fizzy beverages, and so on, we've got a few housekeeping items to go over. Today's session is being recorded, and it will be shared with you next week. We're going to take about 45 minutes, and we'll have time for Q&A afterwards for live attendees. Please send your questions early in the Zoom chat or to me privately if that's your preference, and we'll do our best to address them at the end of the session. Lastly, this webinar and all of our DPE events are made possible by the support only of our hundreds of happy Develocity customers, including Pinterest, at whose headquarters we are today hosting a DPE city tour in San Francisco, including speakers from Pinterest, Netflix, and Gradle. So that's happening right now in San Francisco, or later today, rather. All right, that's it from me. Let's hand it over to Brian. Brian, it's always great to see you. Thank you for joining us today.
Awesome. Well, thanks for the intro, Oliver. I do want to make one correction. I think your intro was pretty spot on, except maybe the expert beekeeper part. Beekeeper, yes. Expert, well, we're getting there.
Well, we're here. We're all here to build some expertise, right? So
absolutely. We're always learning. All right. So while people are still joining here, let's play a little game, right? So, well, let me give you a little background first. So, as Oliver mentioned, there'll be at least 18 different tips I will give you. You don't need to be a Maven expert. So if you use Maven for a little bit, or you have like, I don't know, some Gradle and some Maven in the place you work, you should be able to pick up on most of these. If not, you should have enough information at the end of this to at least know what you should Google. Right. And that's the important bit. Most of my brain is offloaded to Google or maybe now ChatGPT. All right. So let's play a little game. There's still a few folks joining. So we're going to test out, I don't know, the chat. Right. So you know the drill. So if you're a fan of tabs, write tabs in the chat. If you're a fan of spaces, write spaces. That way you can argue amongst each other the rest of the 45 minutes here. If you have not seen this episode of Silicon Valley, go YouTube this clip, just tabs or spaces, Silicon Valley, and you'll find it. It's a riot. It will make you laugh regardless of which side you're on. I am on the side of spaces. So you can yell at me in the chat as well. People are coming through. It's great. Of course, you probably saw this coming, right? That's a nice lead up to this. So this talk is not about Gradle. But I do want to explain why we're talking about Gradle today, right? So if you're a fan of Gradle build tool, you could put that in the chat. If you're a fan of Maven, you can put that. If you're a fan of both, that's cool too. Let us know in the chat. Obviously, I am a big fan of Maven. So there is this kind of elephant in the room, right? So why is Gradle talking about Maven? Why is a Maven guy talking about Gradle? Or for that, why am I working at Gradle, right? So just to clear this up before we keep moving here. So Gradle, the company who signs my paychecks, created Gradle build tool. And that's what we all think about when we hear Gradle, we think of the build tool. But we also have a commercial product that Oliver mentioned called Develocity. And that's all about making your builds faster and making you more productive, right? So that works with Gradle build tool, Maven, Bazel, SBT, and we even have beta support for NPM in Python. So really, we don't care which build tool you're using, as long as you're productive. And we like to talk about developer productivity engineering. We want to engineer ourselves into being more productive. All right. So with that out of the way, let's jump into it. Okay. So the biggest complaint that I feel like I keep hearing, I don't know, all the time, every time I go to an event and talk to folks, is that they don't like XML, right? So that's why they don't like Maven. It's XML. Well, historically, if you think back 20 years ago, we put XML in literally everything we could. If anyone's ever used SAML and is aware of the problems that come with SAML, many of those are related to XML. Okay, so we just kind of overused it. Now, if Maven was created today, I bet we'd use YAML, right? So today we do the same thing. It's just instead of XML, it's YAML. So it's kind of the same pain, just a different markup. But I don't think their complaint is actually about XML. It's more about it's not programmatic, right? I feel like in the case of Maven, that's a good thing. I feel like a heavily programmatic build adds a lot of complexity, and that's something we should try to avoid. There's enough complexity in our builds already, so removing that where we can is a good thing, at least in my view. I will say, if I could specify a dependency as a single line instead of like 5 lines of XML, I'd be pretty happy. So I'll concede with that. Okay, so I'm going to break this talk up into a few different sections. There's going to be a quick demo at the beginning. I'm going to talk about test and some test hygiene. We'll talk about your general Maven tips. So all of these things apply to Maven, but we'll talk about some specific Maven tips. I'm going to talk about how those tips can relate to CI, and then we'll talk about dependency hell. Everybody has probably been through dependency hell, so I'm going to give you some tips to get out of it. So if you want to make your build faster or your application faster or whatever you're doing, the first thing you need to do is measure. Okay. You might need to measure just to tell your boss, hey, I made this thing 20% faster. That may be the reason why you need to measure. But you need to set some sort of baseline, because if you just say the build is faster, that's very subjective without data to back it up. So I found this acronym MOM recently. It was some Medium post. I probably should have linked it here, but I'm sure if you Google it, you'll find it. It's measure, optimize, monitor. And I really like this. So the first thing we're going to do is measure. Right? Then we're going to make some changes to optimize our build or your application. And then we're going to monitor it continuously to make sure we don't regress. So, when in doubt, ask your mom, right? All right. So I'm going to walk through this quick demo. This demo is based on a blog post I wrote. So there's a QR code. You can go to this link here. And I'll go through this pretty quick, and then I'll get through everything we're talking about in more detail. But I want to give you at least a quick overview of the types of changes you can expect to see by applying some of these changes. So I'm going to jump over to my IDE, and hopefully I've got everything set up. So this is Apache Skimple. It's under the directory project. This project doesn't actually matter in case of this talk, but the build is about 1.5 minutes, 2 minutes. So it's a great amount of time that I can run the build a couple times and we can talk about it. Many of us have builds that are 20 minutes, 40 minutes, an hour long. And obviously that's probably more typical of a large code base. This code base has like 30,000 lines of code. It's got, 14-ish modules. But it's got a good, pretty representation of your typical build. It generates a lot of jars, Uber jars. It's got some examples with war files. It generates code. It's got unit tests, integration tests. So it's, there's a lot going on here that you'll find in a larger project, just at a smaller scale. And, if I picked a project that was 45 minutes and I built it, we'd be spending the whole time in this talk waiting for it to finish. So I'm going to run nvn clean install, and then I'm going to talk about really briefly the changes that I'm going to apply here, and I'm going to make the build faster. And every one of these changes I'm going to walk through in a little more detail in a few minutes. So bear with me. So GitHub sorts everything alphabetically. So there's a couple XML files at the beginning here. So this first one, I've applied the Develocity extension that's adding build scan. So that's what I'm using to monitor or measure. And I'm also going to apply the extensions with a Maven extension.xml. And so that's kind of some boilerplate code. So there's nothing super exciting there. But now if we continue down, we'll see some changes that I'm making. So first up, I'm going to add a Maven config file. And then I'm going to specify the --threads command. So now I'm going to run my build in parallel. So I'm going to use 1.5 times the number of cores that I have on my laptop. The next file is I'm going to use the Maven wrapper. And along with the wrapper, I'm going to use the Maven daemon. And like I said, I'm going to get through all of these in more detail in a few minutes here. So I'll show you the profile information from this build. But one of the big slow points is spot bugs in PMD, at least in my build. So I'm going to move them into a profile. So you can see my profiles, XML, I'm going to call it CI. I want those things to run in CI, and I'll explain why in a little bit as well. But I'm moving them into CI, and I'm going to run my tests, both my unit test and my integration test in parallel. So all of those things are going to speed up my build. So I don't know, there's 4 or 5 things just in this quick little diff that will reduce my build time. So hopefully my build is finished. So let me switch back here, and we can see it took about 1.5 minutes. Now I'm going to go really quickly through, this is actually the link I wanted to show. So this is a build I did before this talk yesterday, just getting ready. It's the same code. But if we take a quick look at the build, right? So this is scans.gradle.com. I'll talk about this a little bit after, but really I'm interested right now in the profile information. So I can see the longest things that in this build were spot bugs, my integration tests, my unit tests, some PMD, and compilation, right? I'm running clean builds every time. So there's a lot of extra compilation I have to do. So that gives me a great quick overview of like where are the pain points in this build. All right, so let me get back to my IDE. I'm going to apply those changes. So I'll do git. Whoop, something's really not working in my keyboard. I don't know what's going on. I'll blame Zoom. I called it blog and faster build. Okay, so I'm going to run mvnw. I'm going to use the wrapper, which will kick off the Maven daemon. I'm going to do a clean verify. This time I'm going to skip the install phase, and I'm going to talk about that in a little bit too. So this time I'm going to expect the build to be much faster. So on my machine is a few years old at this point. It's a laptop. It's an M1 Mac Max, I think. So if you have a newer laptop, you can kind of expect to be faster. One of the things we did at Gradle when the Apple Silicon or M1 Max were coming out is we did some profile information. We found out that the M1 Max for our builds were faster than the Intel Max. So we upgraded all of our engineering machines to M1 Max. Because we had data, we were able to find out our developers would be more productive with newer laptops. So it might actually be pretty cheap to make your developers happy and give them some new laptops. So, but you have to measure, you have to monitor your builds to know that. All right, so this build took about 30 seconds. So I've cut whatever, 1 minute off, but really it's like, 2/3, 66% off of my build. So that's pretty impressive for, very little work. But I mentioned I added a build cache. So if I run the same build again, this time, really there's no work to be done. Right? So I didn't make any changes between these 2 builds. So really it's going to take 6.5 seconds or so. So that's I think much better. It's kind of a vanity number. My builds aren't going to be 6 seconds because as soon as I start making changes to my code base, I'm going to have to do some work. But I would expect all my builds to be somewhere between 6 seconds and 30 seconds for this project. And if we switch back to another build scan, somewhere over here, I can see that really all that's happening in my build is this remote resources plugin and the enforcer plugin. So there's still some optimizations I could make, but that's pretty good for, a couple of tweaks to a POM file. All right, so let me get back to my slides. Like I said, you can go here, read this blog post, and walk through all these steps directly if you want to try it out. And all of these steps could apply very similar to your projects. This is not, there's nothing obviously here that's specific to Apache Skimple. All right, so let's move in and talk about tests. I think tests are probably one of the most important things, if not the most important things you can do in your build. When I talk about build time, I'm including the time it takes for my test to run. I want to run my tests. I think they're very important. If I'm making a dependency change, right, or an update, I want the tests run. That's the only way that I know that change didn't break something, right? And we're updating dependencies all the time. I want to make sure nothing broke. And of course, as I'm developing features, I want to make sure I'm not regressing right? The typical reasons why you write your tests. So I think you need to be able to run an individual test. So any test you'll be able to run individually. So many of us have seen how to do this on the command line. So, Maven test and -d test, and, you start typing all this stuff out, your class name, and then you can, if you want to run a single method, it's pound and then the method name. So that's not too bad. If you want to do this for integration tests, it's very similar. Instead of running tests, you run verify, and you typically replace everything that was test with it.test, right? So this is fine. However, in the Maven world, if you run verify, I'm going to run all my unit tests. So this is actually not running a single test. This is running one integration test and a whole bunch of unit tests, potentially. So I'm going to skip my unit tests. So I'll run this -d test none at the end, and I'll skip my unit tests. However, that's going to fail, right? So Surefire Maven is going to yell at me. It's going to say, you didn't actually match any unit tests. You're going to fail. So then I have to remember to add this other command line flag, right? And you can see where I'm going here, that this gets verbose real quick. I know all of these things, right? And I still don't want to type them. I would rather just wait the extra few minutes for the build to run than have to remember to run all of these, type all of these commands. So there's a better way. And I'm guessing some of you in the chat are already talking about this. You should be able to run all of these things from your IDE, right? Don't make a developer think about extra stuff. I want to think about the problem I'm working on, and then I want to click a button real quick, and I want to get feedback really fast, right? So maybe I'm working on this in a register repository test. I'm going to click the run button. It's going to give me feedback, and then I'm going to keep going. I can run all the tests in that class. I can run all the tests in a package. That's what I typically do. I run, if I'm making changes within a class or two, I'll run all the tests in that package. And then in IntelliJ, I'll run all the failed tests until I can get them all passing. And then, of course, I'll run all the tests again. So this way, you're context switching less. You're able to stay way more productive. And you don't have to remember the incantations on the command line. And I love the command line, but really, I don't want to spend that extra brain power or time it takes to type something out. So click of a button in your IDE. So that means if you are at a shop where you need to do extra things to set up unit tests or integration test fixtures in a Maven build, you shouldn't be doing them in the Maven build. You should be doing them in a test framework like test containers or something like that. Start those things at the beginning of your test, and then when all your tests are done, there's JUnit and TestNG have support for all of those things. And it'll just make all your developers more productive. I know I worked at shops where you had to run tests from the command line. It's a major pain. So let us know if you're in that boat. All right, I've touched on this already, but I feel like you should be separating your unit tests and your integration tests. Many of us have unit tests that are probably actually integration tests, right? Those unit tests are connecting to a database or a REST API or some other service. Well, that's not a unit test, right? We could get really, really rigid in saying what a unit test is and what an integration test is. But, the line in the sand for me is if your test is connecting to an external service or starting up some sort of Spring context, it's not actually a unit test. So separating those tests out helps you think about which test should be really fast and which test could be take a little longer, slower feedback. Potentially there's more flakiness if some service is down, right? Maven supports both of these. The Surefire plugin supports unit tests. The Failsafe plugin supports integration tests. Both of those plugins are 99% the same. The Failsafe plugin adds a little bit of sugar at the end to start and stop services. But I just said you probably shouldn't be doing that anyway. But it still forces you to separate those types of tests. And all your code coverage tools like Jacoco, all of those things will separate the test coverage for both sets. So I like to joke, if you have 50% unit test coverage and 50% integration test coverage, that is not 100% code coverage, right? Because there's overlap. So at worst, it's 50% code coverage. At best, it's probably, 60, 70% coverage. Because, it's coverage. It's not, you can't add them, but all of the code coverage tools support aggregating all that information. All right, so the last tip I want to leave you for testing is running tests in parallel. So you saw this in the demo. I had the JUnit configuration to run my test in parallel. There's basically two major ways you can do this. You can have a single JVM run each test in multiple threads. So in my case, I have one JVM and you can see 4 threads are running, and that's how my tests are being executed. And then I could use the -d fork count, or in my POM file, I can use the fork count option, and every fork will fork a new JVM, and each one of those JVMs will run tests sequentially, right? But I can combine those two as well. So I could have multiple JVMs, each running multiple threads. So how you do this is really up to you. I would say best case scenario is the first option, where everything runs in multiple threads. But depending on the type of logic and how your code is written, you might need to fall back to forks. And that's because turning on parallel testing isn't just something you can flip a switch. It really depends a lot on how you've written your tests and kind of test hygiene. So if you have tests that are sharing files, right? So right now, if your tests are running sequentially and all the output or whatever is going to a single file, or you're writing to a file and then reading from that file, and you run those tests at the same time, they're going to trample on each other. Same thing with hard-coded ports, right? Many of us have tests with hard-coded ports. I don't know, port 80, 81, or whatever. So you can't start 2 application servers on the same port. So you need to start using ephemeral ports or a random port. If you're setting system properties, right, you can't do that. So some of these, if you're setting system properties, that would be a great example of, you could use the fork count instead of multiple threads. But really, cleaning this stuff up in your tests, I think is a good practice to follow. Even if you're not trying to get your tests running in parallel, it will stabilize your tests. You'll be able to run your tests individually and not have to worry about the test interacting with something that's already run. So it's still a good practice to get into. I know I've written tests where there was some flakiness because the test order caused some flakiness, and that had to do with some file that multiple tests were using. So the output of one test would change kind of the input of another test. And so depending on the order the test ran, the test would fail. And that was, that's a test error. But it's common to see those things. So before you start going into the parallel test world, you may need to clean that stuff up. Okay, so let's move and we'll talk about some Maven tips. So if you didn't know, this is actually the Maven owl. So this is a logo for the Apache Maven project. I didn't know about this until a few years ago. Sad to admit. So I don't know, some of you may be in the similar boat. I don't think this thing actually appears very many times on the Maven website, but I think it was on their Twitter handle and things for a while. So it's not really a tip, but it's a fun fact, I guess. So I just got done talking about testing with multiple threads. So I also want to talk about building with multiple threads. So you can think about it this way, right? 2 heads are better than 1. Well, this is a bit funny, but we're going to do 2 threads are better than 1 if you want to remember it that way. But really, it's not just 2; it's multiple threads are better than 1, right? So this is the -- threads command. So if you're not using the Maven daemon, I think I saw a comment. The Maven daemon automatically uses the threads command. I'm going to talk about that in a minute. But if you're not using the Maven daemon, you can stick the -- threads command in a Maven config file. This config file, every line is basically a command line argument. So if you find yourself telling your developers to say, hey, always run your build with this flag, you should be sticking it in this file. Don't make everybody think about the flags they should type every day. Automate this stuff, stick it in config files. It's just a lot easier that way. So by default, Maven is going to run everything sequentially. So if you add this flag, it'll run in parallel. So what that kind of looks like is, I have 2 examples. This project A is a very linear graph. So the graph of the project modules are a straight line. So let's pretend that app depends on impl, impl depends on API. So if I run them in parallel, it's not going to matter because API always has to run first, and then the impl project's always going to run, and then the app project's always going to run. So it's a straight line. So parallel building here doesn't help me. But many of us have projects that have a lot more modules. So if we look at project B, let's pretend that the module is structured like this. This is fictitious. I've kind of made this up, but that's kind of all that fits on my slide here, right? So let's pretend that the web app module depends on the service, core, and utility modules, and all of those depend on the model above. So what's going to happen is when Maven runs, it's going to run model first because a lot of other things depend on it, and then it's going to run the service, core, and utility modules all at the same time in different threads. And then when those are all done, it's going to build the web app. So in this case, I've cut off a little bit of time for my build. So instead of running them all at the same time, I've cut off the time it takes to run, I don't know, maybe the core and utility module took less time than the service module. So that's again, dash threads, try it out. If you're doing a lot of silly things where your builds or your tests are outputting some other directory, so if you have tests that write outside of your target directory, you still might have cases where your tests are trampling each other. But for the most part, a project should be pretty isolated. So that might just work for you out of the box. All right, next up, I want to talk about profiles. So again, this was in the example I showed early on. I think profiles are a great way to help speed up your builds. It's really the only programmatic option we have in Maven builds, right? So Maven is basically a bunch of XML, and profiles can be activated with either command line flags, like you see here, a -p CI, or activated automatically, right? So if I'm using a version of Java, I can activate them automatically. Or maybe in the CI case, I'm going to check if the CI environment variable is set. I'm going to run this flag automatically. So I like to take the stance that Maven builds should be fast by default. So in my case, I moved out spot bugs and PMD. I love those plugins. I've learned, I think, the most about secure development with spot bugs and the find sec bugs plugin to spot bugs. But I tie them into my IDE and I get that feedback as I'm typing, right? So I get it constantly. So I don't need my local developer builds to tell me what my IDE is already telling me. And when my IDE gives me that feedback, it's instant. It's in the context of what I'm doing. It's not 10 minutes later. So it's a much better place to give your developers that feedback. But my theory is your developer build should be fast by default. That way, developers don't need to think about which flags I should put on the command line to make it a little faster. If you've ever released anything to Maven Central, or you're doing something similar internally at your company, oftentimes we have a release flag, and that hides a lot of complexity that's needed to upload things to Maven Central, like cryptographically signing artifacts, producing source jars, Javadoc jars. Those types of things are often hidden behind the release flag because it's another one of those things you don't need to build every time for a local developer build. You can go the other way, of course. You can say, by default, you want a full build, and then you want your developers to use a quick profile. Maybe that runs a reduced set of tests or something. You can do that as well. That's up to you. Like I said, my preference is the other way around, but there's nothing wrong with this option as well. But just know that profiles are a way to split up some logic. The last thing I'll say about profiles is if you're still stuck on Java 8, if you're brave enough to admit you're still using Java 8, you can stick that in the chat. Hopefully no one will make fun of you. A lot of us are still in the same boat, unfortunately. But profiles are a great way to help you move forward. So if every day you're using Java 8, you can create a profile for Java 21 and add all of the extra arguments, like add opens or whatever you need to do to tweak the build for newer versions of Java. You can do that in a profile, and that'll help you migrate forward, and you don't have to be stuck on Java 8 forever. Maven 4 is going to require at least Java 17, at least initially. So you can still compile and target down to Java 8, but your build itself will be running on a newer version of Java. So if you're really in that camp where you're stuck on Java 8, please move forward. Open source libraries are going to drop you soon. So we all need to move forward. All right. So next tip. So I think there was a few comments about me running install earlier. So that was intentional. So if anyone's seen Andre's memes, I think he's done the most to educate the populace on this topic, and he's done it through memes. So that's kind of how we learn now, is through memes, which is both funny and possibly sad. I don't know. It's great though. These are great. I think he still does these. This one was from a few years ago. But essentially, the idea is running Maven Verify is better than running clean install. So all the core Maven plugins are a little better than they used to be years ago. So they should all, you shouldn't have to run clean to make them run correctly the second time. Third-party plugins, I don't know, you're kind of on your own. Hopefully, if you're using quality third-party plugins, they don't need a clean either. But let's talk about the install versus verify for a bit. So this is a daunting list. So this is all of the Maven build life cycles or phases that you could run on your build. So on the command line, you could type mvn validate or mvn generate sources, and everything will run from the top all the way to what you pick. And typically we would do verify or install, right? So every one of those phases we're going to run through during our build. This is a really long list. Let's trim this down for a moment. So this is what the phase set looks like for a default jar project. So if you start a project today, these are the phases that have some work attached to them, and the work is a goal, right? So if you think about, if you're a typical jar project, what's going to happen is you're going to copy your bits from source main resources into the classes directory. You're going to do compilation, and you're going to do the same thing again for your tests. Then you're going to run your tests. Then you're going to create jars, right? Or jar. And then you're going to install the jar. So copy the jar from your target directory over to your home directory. And then if you're deploying this to a Maven repository, you're going to upload it to some repo. And a local developer probably isn't doing that last step. But the meme or the conventional wisdom says you probably don't need to run the install. You can stop at verify. But verify isn't on this list. So why do we say verify? Well, right in the middle here is verify, and that's usually where we attach all of our other logic to. So if we're doing, I don't know, PMD, check style, Jacoco, integration test, all of those things typically have some component in the verify stage. So that's why we say if you can run to verify, your build is good, right? You don't need to install. You don't need to deploy, obviously, because all that's doing is just copying bits from point A to point B, and that's probably not something you need to do for your local build. There are some caveats here. I typically work on libraries. So I talked about Apache Skimple. That's a library or framework. So I typically run MVN verify, and that's all I need. If I have two projects, so I'm building a library and then I'm consuming that library, I do need to install the library before I can consume it. So don't just forget about install. But if you're building web apps, right? If you're just working on one code that builds a web app and you run that web app, you don't need to run install. You can just run verify. Again, there's still some edge cases here, but by default, run verify, and you should be good 99% of the time. I will say, let's look at this quick build scan here. So this is very similar to what I showed you earlier. And I want to highlight the amount of time it took my build to run install was 0.11 seconds. So big deal, right? Yes and no, right? So my machine has an SSD in it. Copying files on an SSD in the same partition is basically nothing. So maybe there's some disk space issues potentially, but really it's not a big deal. Now, this isn't always the case. I've seen a lot of customers where they're on Windows and they have weird NTFS or network mounted home directories, and for whatever reason, they're copying everything over the network or over a different drive. So the time added from installing, just copying those bits, adds up real quick, especially if you're generating large Uber jars or wars. So I would still say by default, at least have it in your mind to run verify instead of install. All right. So let's move a little quicker here. So I talked about the Maven daemon. So the Maven daemon is relatively new. It's at like version 1.0.2. So it does a lot of the things that I've talked about for you by default. And it basically keeps a JVM running and warm, and all the just-in-time compilations happened. So the JVM should be a little faster. You don't have to incur the cost of starting the JVM every time you run Maven. The output is a little better, a little nicer formatted. It adds the -- threads command more or less for you. It does it in a slightly smarter way. So I think if I remember right, it takes the number of cores you have on your machine, subtracts 1, and uses that number. So you can probably get a lot of mileage just by using the daemon. So go check that out. And of course, I love to talk about build cache. I could spend a whole lot of time talking about that. I've actually written a whole course on build cache. So it's a great way to speed up your builds. If you have large builds and you're doing a lot of things, but you're only working on a small portion of your build, you should probably only have to build and compile and test that small portion of your build. So everything else can be ignored, right? So if that work has already been done by you or your CI system, you can take advantage of that work, that computation. So your builds will be much, much faster. So definitely take a look at build caching. There's a couple options. There's the Develocity Maven extension, which adds build caching and build scans, which I've been using. And the Apache Maven build cache is also an option for you. All right. So moving along here, let's talk about CI build configurations. So this is kind of one of those things that are outside the control of Maven, right? There's nothing that Maven can do to make your CI faster if you haven't configured things correctly. So one of the biggest things that I think we see often is people running multiple Maven executions sequentially. So this is a Jenkins file. Forgive me, I haven't used Jenkins in I don't know how long, but I hope the syntax looks correct. It's for GitHub Actions, it's very similar to this. GitHub has as jobs and steps. So if you have a lot of steps that are sequential, you can think about it the same way. So essentially what's going on here is I'm going to add some debug logic to my build, and I'll talk about why you can get rid of that later. Maybe I'm going to do some static analysis, and then I'm going to run my full build, right? So I'm running four invocations of Maven. Well, really, I can reduce that down, or at least I can get them to run in parallel by adding this, in the Jenkins world, this parallel step. Different CI vendors, everything's going to be slightly different, but hopefully you see where I'm going here. Run these things in parallel. That way, instead of, if every one of these steps is 2 minutes, I have 3-4 different steps, so that's 6 minutes. I can reduce my CI feedback loop down to 2 minutes. So that's significant. So I'm also a big fan of, I've seen the -- version output in a lot of builds for some reason, but you can just use the -v command. I don't think you should be running the dependency tree in your build either. I have seen that a lot. People do that for debugging reasons or whatever. Again, I'll talk about replacements for that afterwards. This example is a bit contrived, but hopefully you see where I'm going. Run things in parallel. Your CI feedback will be much faster. Next up, I want to talk about ephemeral builds. So we all kind of love ephemeral builds nowadays, ever since sort of GitHub Actions, took over. So ephemeral build is basically all your builds start from a clean slate all the time, which is great because now there's no previous state left around on my build to screw things up. So that's awesome. The downside is my builds are now much slower, right? Because I'm starting from a clean slate every time. So essentially what is happening here is I'm going to run a build that's going to download the world, right? It's going to download all my dependencies, everything. And then after the build, all that stuff gets removed. It doesn't actually get cleaned up this way, but logically it's the same thing that happened. That VM or Docker or whatever instance is just removed. So all of that downloading just evaporates. And then I'm going to run another build, and then I'm going to download the world again. So there are ways around this. So in the case of GitHub Actions, there's a setup Java action that will turn on the caching of your local Maven repository. Jenkins has another plugin that will do some caching of the Maven repository for you. And I think there's some configuration there that you can do that to optimize your builds. So definitely take a look at those options. It is important. I want to point out that if you're reusing your local Maven repository, you should not be doing an install. So install copies stuff from your target directory into that repository directory, and then you're going to reuse that in the next build. So that's going to kind of taint your cache a little bit. So ideally, you want to just run verify and not copy your bits into something that you're reusing later. But that's just a slight optimization there. All right, so moving forward, I gotta move a little quicker here. We got to get through our dependency hell section. So I think every build tool has kind of this dependency hell. This is not unique to Maven, right? Gradle has this, but also NPM, Python, any package manager has package conflicts, and it's just something we see all the time. So in the Maven world, I highly recommend spending a lot of time looking into dependency management. So I could spend a whole talk talking about dependency management, but I'll give you the quick TLDR here is that dependency management is essentially a lookup table or a defaults lookup table. In my case, I'm going to set the default version and the default scope for SLF for J simple to whatever 2013 in the default scope to test. And then later on in my project, maybe in a submodule, I'm going to use it like this. So now I have the versions defined in one place, which is a good thing. And what happens in Maven is going to resolve that dependency in memory, and it's going to look something like this. So that's great. So I saved myself a couple lines of typing, but I've defined my version somewhere else, and I'm using it, and that's good. I will say I don't think you should put scopes in dependency management. So what happens is, I'm going to look at this 6 months from now, and I'm going to say, well, the default scope in Maven is compile. So I'm going to assume that I'm going to pull in SLF for J. It's going to be on my class path, the compile class path for whatever reason. I'm just going to assume that because I don't want to dig through my POM files to figure this out. I'm just going to, naturally assume that. So when it gets to resolve to test, maybe that's going to confuse me, right? So I would say leave the scopes at the default settings, even for your test, your test dependencies. Just add scope test in a few extra places. It'll make your developers have to think less as they go through your POM. So it's kind of a quality of life thing. I think it makes just your POMs easier to read. All right, I don't want to spend a whole lot of time on dependency ranges. If you are using a dependency range, stop. That's really the answer to that. Don't use a dependency range. So if you have something like this in your POM, don't do it. One of the big arguments I've heard in favor of dependency ranges comes from library developers. They say, well, my library should work with version, a bunch of versions. We use Semver. Our dependencies use Semver. It shouldn't matter. Well, I will say that the versions defined in your POM aren't telling other people what you support. They're telling other people what you tested against, right? If somebody else wants to use a newer version of something, there's no guarantee that I can make that my dependency follows Semver to the letter, right? So don't use a version range. Things will resolve one way on my machine, and then, an hour later, they're going to resolve differently in CI or worse. What happens is, maybe you have to maintain a branch from 6 months ago. And if you use ranges, the dependencies are going to be resolved completely differently, and you're going to spend a lot of time digging through dependency hell, and it's just not something you want to deal with. So just don't use version ranges. Pin the versions of your tools. So the Maven wrapper I talked about, the Maven wrapper is actually even easier to use. So in this screenshot is a bit old, so you can see the .java file and the .jar file. There's a script only option with the Maven wrapper now that avoids needing these two altogether, which will speed up, I shouldn't say speed up. It will just avoid needing to download a jar or do the compilation. But really, it'll make your security teams happy. A lot of security teams don't want binaries checked in to to repositories. So not needing to have that there simplifies things greatly. Just like the Maven wrapper, you can use the Maven, SDK man or something like that to pin the version of Java. So, but these tools allow you to specify the version in a config file. In the case of SDK man, there's an SDK man RC or some other equivalent tool. But that way, all your developers are using the same version of Maven, the same version of Java. Your CI system uses the same version of Maven, the same version of Java. It's really easy to upgrade and manage your whole team that way. All right, dependency tree. If everyone's never looked at a dependency tree, dependencies are a graph, right? So if you type dependency tree, you'll see something like this, where my dependencies have dependencies, those dependencies have dependencies. Those are my transitive dependencies, right? Even if I don't specify them, they're still part of my application. So I touched on this earlier. If you're using something like build scans, you get the dependency information for you automatically. So you can look at scans.gradle.com or Develocity, and all of that information is collected for every build. So you don't have to go, check out that branch and run dependency tree to figure it out. It was automatically collected, so you can just go search through the dependency list that way, and hopefully it'll make you a little more productive. The enforcer plugin is another way that will help you kind of block dependencies. So the enforcer plugin is basically saying this must be true for the build to fail. For the build to pass. So in my case, I have two enforcer rules. I'm going to ban or fail the build if I see Commons logging under 1.3. So if you've ever used Commons logging, the older versions don't work well with SLF or J. So maybe you want to exclude those dependencies. Maven does not have an exclusion option, a global exclude. So anytime your dependency is pulling in some transitive dependency that you don't want, you need to explicitly exclude it everywhere. It's kind of a pain, but the enforcer plugin at least guarantees that those things won't accidentally show up on your command, your class path. And the dependency convergence rule here will basically says if two versions of something are detected in my dependency graph, I'm going to fail and basically require me to put that in dependency management. So I won't have version conflicts, or I won't grab one version when I expected the other version. All right. Last up, I want to talk about dependencies. So just in general, most of your application is dependencies, right? So you need to have a plan to manage your dependencies. And that could be end of life issues, but more importantly, that's security issues. There are more than 50 vulnerabilities reported every day. You need to have a plan to update your dependencies. I don't care what it is. Use some bot. There's a handful of bots: Sneak, Sonatype, GitHub, Renovate. Find a bot you like, use it, and update your dependencies automatically for you. You need to have tests if you're doing this. You can't just update your palms without tests because you don't know if that dependency change is going to break something in your application. So in order to have a good security posture, you also need to have good tests. All right, the last thing I'll say about dependencies is shrink them. Reduce the set of dependencies to as small as possible if you can, right? That reduces the surface area of your applications. And I'm not telling you to replace open source libraries with some custom code you wrote over the weekend. No, I'm just saying, you probably don't need 3 JSON parsers on your class path, or 3 string util libraries, right? So use what you already have. If you're building a Spring Boot application, use Jackson in the Spring Utils classes, right? So that means you can get rid of anything that's using JSON.org or JSON.org or JSON or Guava or any of that stuff. So it's just an easy way to reduce your dependency set down. All right. So it's a bit long-winded. So we have time for questions. So I'll leave this QR code up here. So that's scans.gradle.com. So you can try it out with your builds. And, like I said, you can find out what the slow points are in your build. You can add a build cache. And hopefully your builds be a lot faster. And then let us know how much faster they are, or at least where your pain points are. All
All
right.
right.
What have we
Thank,
got for questions,
yeah.
Oliver?
Yeah, we've got some good questions. There's also a little bit of debating in the chat going on too, which I love to see. What
Awesome.
I've noticed.
What did I say wrong? Maybe we should
No, no,
start there.
no, no. Debated, not really debating, just kind of really, really actually useful conversations. There's some
Excellent.
people in the chat that obviously have some experience with some of the tips and hacks you've been discussing, and they're providing nice insights to others in the chat, which is something I've been noticing in our webinars. I really like it.
Awesome.
So,
Community. That's
thank
where
you.
you learn everything, right?
Yeah, yeah. So thank you very much, Brian. This was an awesome presentation. I just want to say before we get to the Q&A, if you're already familiar with BuildScan and you know what you're getting out of that, we want to invite you to request a guided trial with Gradle. And in a guided trial of Develocity, you'll work hand in hand with our expert engineers to help you prove an actual ROI, what you can accelerate, how you can troubleshoot faster, et cetera, et cetera. So if you're game for that, I invite you to go to our website, click on Request a Trial, and you'll be in good hands with us. So let's get to some questions. Let's see. Let's start with a couple of the newbie questions. Is it better to use Maven install for each build or Maven compile because I'm doing a lot of JUnit testing? And in which case, this person is using Maven clean test. So he qualified this as newbie question.
Yeah. So if you're running a lot of unit tests, you want to at least run tests, right? So if you're not using a build cache and you're not using a lot of random third-party plugins, you can probably just run MVN test over and over again. You don't need to run all the way to verify. If you just want to run your unit test, if you do want to run, your other bits, static analysis or those things, that's why we typically say verify, because it's kind of a one size fits all. But if you just want to focus on unit tests, MVN tests, you don't need to run compile first. If you run MVN test, the compile and all of the other stuff will get kicked off automatically for you. So just the MVN test will work in that case.
All right, great. Here's an interesting one. I'm going to read the question so it's a little easier. Quote, I'm used to running Maven through IntelliJ IDEA, but IDEA doesn't use the wrapper command, and instead it hooks pretty deep into Maven and takes over. And that's not very compatible with Maven D. Do you have any hack for that? It doesn't work out of the box. Even if you configure IDEA to use the wrapper, it will not use the wrapper script, but include the jars and take over how it executes.
Yeah, that's a great question. No, I've seen that before. I in demos I don't use the Maven integration because it's more explicit when I type it out on the command line. It's essentially doing the same thing, but like you mentioned, IntelliJ ties in deeper. The daemon is pretty new. I think it came out within, I don't know, a year and a half or so. Don't quote me on that. So I think the IntelliJ folks are probably a little further behind with supporting it. So there may already be an IntelliJ issue for that. So if not, I would recommend going and filing an issue with the JetBrains folks and tell them that's what you want.
Yeah, why not? Just go contact the IntelliJ folks. Let them know what you think.
Yeah.
Let's see. Do you know if the Maven daemon mixes well with Dockerized builds? And this is a question I haven't actually heard before, and I'm wondering if you have any insights on that.
So I think that depends what you mean by Dockerized build. So if you are using Docker to run Maven, then probably not, right? So if Docker is starting running Maven and then stopping, you're going to lose all of that, everything that's running. If you're using Maven to build Docker images, that's probably not a problem. But I'm guessing it's the former. So that's not going to work with the Maven daemon because of the way you chose to run your build. You're choosing kind of the Docker isolation as opposed to a long running process. So you would have to change how you do your builds. You could potentially run the Maven daemon in a Docker container, potentially. I don't know all the tweaking you would need to do because there's some communication that happens between the Maven daemon server, so to speak, and the client. But theoretically, it's possible if you open ports or sockets. That's probably not worth digging into, but it's something that if a lot of people are doing, that's probably something that could be added to the Maven daemon project itself.
Right, great answer. Let's see. There was a very early question, so this was about when you were looking at multi-threading. And maybe it's been so long since that slide, the context might be a little tough to grasp for you. But the question is, as you set threads, what about non-thread safe dependencies?
Yes. So that was exactly what I was touching on with the the funny meme there. Like it's not just a turn it on and it works. You will have some tweaking you probably have to do. And that gets back to kind of, like I said, test hygiene. But if you're using a lot of dependencies that are not thread safe, that's kind of a sign or a smell you might not want to use that dependency. If you're using a lot of singletons, for example, old school singleton patterns, you can't run those in parallel because, in one JVM, you have a single instance. You could do something with multiple class loaders and you could fudge it somewhere, but that's really, the complexity is probably not worth what you're getting out of it. So I would say it really depends on that library, why you're using it, how you're using it. Again, if you're using something that is setting a lot of state like that, you might be out of luck. That's where the fork count option comes in. So running them in multiple JVMs removes some of that JVM specific state. You will potentially run into issues if you're sharing ports or files. But if you're just sharing, system properties or static variables or whatever, the fork count option would be your best bet forward. It's a little slower to start JVMs, right? Because you're starting a JVM, running a bunch of tests, but it's still the most bang for your buck in that case is probably just use the fork count.
Great. We've got time for a couple more. Let's see. This is kind of a two-parter, or rather, the attendee asked two questions in a row. Is it true that in most cases Maven install should be faster than Maven clean install?
Yes. Yeah. So anytime you do a clean, you're essentially deleting the target directory. And then what that means is you're forcing the compiler to do all of the compilation again. So if you have a million lines of code, that's going to take a significant amount of time. My example had, 30,000 lines of code. So it was pretty quick. If you're using a build cache, the build cache makes up for that difference by pulling things out of the cache instead of redoing the work. So that's why you can run a clean with a build cache. But if you're using plugins that respect clean, you can usually get away without running the clean. But there's a big caveat there. So I would say try it with your build. If it doesn't work, it's because you're using some plugin that breaks something. Like I know, like the old version of like the bind plugin, if you're doing OSGI, doesn't work well with running clean. Doesn't work well with not running clean. I have all kinds to say about that plugin all by itself, but I'll keep that to myself. But yeah, I would say try it. If it works for if not running clean works for you and it works for your build, do that. And it will make you a little more productive. It'll save a little bit of compilation time.
Nice. The same person also asks, is there a clever way to execute only tests that could have been affected by changes since the last run?
Yes.
I already mentioned predictive test selection in the chat.
Yeah. So we have a whole suite of tools that do exactly that. There isn't a way built into Maven because Maven doesn't know how your tests affect the code, the code you change, right? So a build cache will help. So depending on like I can get into the details of the Devvelocity build cache. If you write some code that's specific to one module, and we do some compiler avoidance as well. So we can reduce the amount of compilation time it takes to do that. You're still going to end up running all of your tests, but if you use our predictive test selection feature, we have a machine learning model that will look at the code changes and the history of those build. It will figure out how those connections are related from your code to your test and only run the appropriate test that might fail. So if the model detects this test has a high likelihood of passing, you don't need it. You don't, right? Because you already have that feedback. It's got a high likelihood of passing. If something can potentially fail, it would fail in that case. Or if it passes, then you're getting really fast feedback. So it's a much more complex answer, I think, than you were looking for, but that's all that's out there. And that works with Gradle as well. So it's the same kind of problem. You have dependencies, you have code, and you have tests, and there's no direct connection, between them without some sort of, machine learning model that sits on top.
Okay, great. And final quick one. Can I use SDK-Man or something similar to download the Java version to be used for the build, similar to toolchains in Gradle?
Yes. Yes, you absolutely can. That's what I recommend. That was my plug for SDK Man. I usually use SDK Man for a lot of the projects I work on. It's one of those things that you have to make sure you're doing it in a way that will work for your whole team or whole company. So if your company wants to standardize on SDK Man, or there's other tools that will do the same thing, I would say do that. Set the appropriate dot file in your project, and pin the versions that way, upgrade that way, and just make sure everybody's using them.
All right. Well, thank you so much, Brian, for your time and expertise today. Thank you to our audience for tuning in. Again, we recommend you check out BuildScan for Maven. It's gonna change the way you think about seeing what's going on inside of all of your builds and tests, and we think you'll like it. So thanks very much for tuning in, and thank you again, Brian.
Awesome. Thanks everyone for watching.